You are sitting inside, rain hammering the windows like thrown gravel. The sky outside is the color of a bruise, that deep, swollen purple-green that doesn't look entirely real. Lightning strobes somewhere behind the clouds. The wind is doing something violent to the oak tree in your yard, bending it in a direction trees aren't supposed to bend. And then, completely out of nowhere, a single thought enters your mind. The birds? 5 minutes ago, a pair of house sparrows were pecking at the ground near your fence. A chickadee was swinging from the feeder. There was movement everywhere, the effortless, chaotic pulse of a backyard alive with birds. Now, there is nothing. Not a feather, not a sound, just the first fat drops of rain beginning to fall, and an emptiness so complete it almost feels deliberate. They knew they were gone before you even looked up at the clouds.
And that is the part nobody talks about, not where birds go after a storm or how they survive the cold, but the exact moment, the precise invisible signal, when every bird in your neighborhood simultaneously decided the world was about to become dangerous and vanished. What scientists have uncovered about that moment and about everything that happens next will change how you see the sky for the rest of your life. Because what birds do in the hours before, during, and after a violent storm is not simple animal instinct. It is a full biological emergency system, ancient, layered, and in several ways more sophisticated than anything we have engineered to protect ourselves from weather. And it has been happening right outside your window your entire life without you knowing. The first thing to understand is what birds are actually feeling when that storm is still hours away and the sky above you still looks perfectly fine. Deep inside a bird's skull, tucked within the structure of the inner ear, is a cluster of receptor cells so sensitive they make our best scientific instruments look clumsy. This organ, called the paratympanic organ, functions as a biological barometer. It can detect changes in atmospheric pressure measured in fractions of a millibar, changes happening at altitudes and distances that produce no visible sign whatsoever on the ground where you are standing. When a major low-pressure system begins bearing down, birds feel it before any radar sees it. What researchers discovered when they began attaching microsensors to songbirds during storm seasons shocked them. The birds weren't just sensing general pressure drops. They were responding to the rate of change, the speed at which pressure was falling, distinguishing between a passing shower and a multi-day severe weather event with an accuracy that no meteorological model had even attempted at that scale. A bird weighing 11 grams was making a more precise storm forecast than the morning news. And the response that followed was not panic, it was a countdown. Watch your feeders carefully the morning before a serious storm, and you will see something that looks at first like ordinary bird chaos. Chickadees cycling in and out every 30 seconds, juncos that are usually skittish suddenly unwilling to leave, a cardinal sitting at the feeder longer than you have ever seen, eating with a kind of quiet urgency that feels almost human. This is not random. Every bird you are watching is executing a critical biological calculation. A small songbird in cold weather burns through its fat reserves with terrifying efficiency. Its resting metabolism is already running at a speed that would destroy a human heart in minutes. During a storm, when it cannot forage, cannot fly, cannot search, that burn rate continues. Food access drops to zero. The bird must arrive at the moment the storm hits with enough stored calories to survive however long the sky stays dangerous. So the feeding frenzies you are watching is not chaos. It is preparation. Each bird is loading fuel with the focused intensity of someone filling a tank before a long drive into the desert. Except the desert here is measured in hours, not miles. And running out means death, not from thirst, but from the inside, metabolism burning its own tissue, heart failing quietly in the dark while the rain comes down. But here is what is even stranger. Scientists found that the birds don't just eat more, they also shift what they eat. In the hours before a severe storm, many songbirds selectively pursue high-fat food sources, suet, sunflower seeds, fatty berries, with a precision that suggests they understand the caloric math. They are not eating what is convenient. They are eating what will last. And when the last safe window closes, they disappear. Most people assume that birds fly away from a storm, that they sense it coming and simply outrun it, relocating to calmer skies somewhere to the south or east. For most backyard birds, that is physically impossible. A house sparrow cannot outfly a weather system spanning 400 miles. A goldfinch cannot climb above a squall line. These animals are not built for escape. They are built for endurance. And so what they do instead is something so counterintuitive, it took researchers years to document properly. They find the perfect hiding place, and they become almost nothing. Biologists call these locations microhabitats. Not burrows or underground shelters, just the right geometry within existing vegetation. The dense heart of a mature evergreen shrub, the deep interior tangle of a holly hedge, the concave leeward face of a stone wall where wind simply cannot reach. A bird choosing one of these locations is making a calculation about airflow, temperature, and structural protection that would satisfy an engineer. Once inside, the bird faces the wind not at its body, but around it, and then the physics of the bird's own skeleton takes over.
A bird's foot is not gripped onto a branch the way your hand grips a railing. The tendons that control toe flexion in most bird species run in a continuous loop around the ankle joint, meaning the harder a bird is pushed, the more firmly the toes automatically clench. It is a passive mechanical system, requiring no conscious effort, no muscle fatigue, no concentration. A branch can whip violently through a 90-degree arc in a gust, and the bird attached to it experiences that like a passenger in a vehicle. Uncomfortable, perhaps, but structurally secure. It locks on, and it stays locked, even unconscious, for as long as it needs. But the strangest adaptation is still coming. Rain is the threat most people think of first, and in one sense they are right. A bird soaked through to the skin loses its insulation completely. Core temperature crashes. Death from hypothermia can follow in less than an hour, but birds are not soaked through. Not if the system works.
What happens next is genuinely one of the most remarkable things a vertebrate animal can do. A hummingbird, sensing the storm approaching, finds a sheltered perch, often hanging upside down from a thin branch deep inside vegetation, a position that seems insane but is actually structurally efficient. And then it does something with its own nervous system that no human technology can replicate in a living creature. It drops its body temperature deliberately, gradually lowering its internal thermostat from the normal operating temperature of around 40 degrees Celsius down toward whatever the surrounding air provides. Heart rate plummets from over 1,000 beats per minute to fewer than 50. Breathing slows to something that requires instruments to detect. To every outward observer, the bird is dead. It hangs motionless, cold to the touch, unresponsive. This is called torpor, and it is not sleep. Sleep is the body resting while maintaining itself. Torpor is the body pausing itself, suspending its own biological processes to the absolute minimum required to preserve the possibility of waking up. The hummingbird is not waiting out the storm. It has stepped outside of time itself, removed its own metabolic presence from the equation, until the equation changes. When morning light strengthens and temperature rises enough, the body begins restarting. Heart rate climbs, temperature rises. Blood begins moving to the brain. Eyes open, and the bird flies away into the post-storm light, as though nothing happened at all. The storm breaks. Sunlight cuts through the thinning clouds. The wind drops to something manageable. And across your neighborhood, in the hedges and the evergreens and the deep hollow cavities of old trees, birds begin to move again. But this moment, the first hour after the storm, is in many ways more dangerous than the storm itself. The birds that survived emerge with depleted reserves. The feeding frenzy before the storm burned their last casual stores. The hours of torpor or locked birching burned what remained. They are running on almost nothing, and the landscape around them has been transformed. Seeds are buried under standing water. Insects have been washed into the soil. Berries have been stripped from branches. The post-storm world is briefly, terrifyingly empty of food, just as the birds that need it most are at their most desperate. Researchers studying survival rates found that mortality peaks not during extreme weather events, but in the 48 hours that follow. The birds that held on through the storm are lost not to wind or cold, but to the silence that comes after, to the quiet starvation of a temporarily stripped world. This is the window.
This is the moment your feeder matters more than any other. A dish of high-fat seeds placed outside the moment the rain stops is not a nice gesture. For the birds returning from the interior of that hedge, it is an emergency supply drop into a survival scenario. It is the bridge between the storm they survived and the recovery they cannot quite reach on their own. The next time you feel that pressure change in the air, the next time the birds at your feeder shift into that quiet, focused urgency you cannot quite explain, the next time you look out at your yard and find it suddenly, completely empty, you will know what you are seeing.
You are watching a species execute a survival protocol, refined across 60 million years of storms. You are watching animals read the atmosphere with organs we have only just discovered. You are watching creatures that weigh less than a letter prepare their bodies, choose their positions, seal their feathers, and lock their feet around branches that will whip and thrash and hold them through hours of darkness and wind. They do not flee. They do not panic. They prepare. They lock in. They wait.